Hello and welcome to the part 2 video for some basic concepts of chemistry. So today we will discuss about laws of chemical combination. There is actually 5 laws of chemical combination and we will discuss each of them. The first one is the law of conservation of mass. The second one is the law of finite proportion. Third one, the law of multiple proportion, then Gay-Lussac's law and Avogadro's law. So we'll start with this law of conservation of mass. This law of conservation of mass states that when there occurs a chemical or physical change, say R is undergoing some kind of physical or chemical change into P. So it is undergoing any kind of physical or chemical changes, right? Okay. Now, before the change and after the change, if we consider the mass of R and the mass of P, then we will realize that during the change and after the change and before the change, the masses of the total system remains constant. That is, mass remains constant throughout the process. That is, the mass neither created nor destroyed in any kind of changes. So that is the law of conservation of mass. Next we have law of finite proportion. So according to this law, any kind of substance, say H2O or ammonia, or you take any kind of substance like copper sulfate. So the percentage of composition, that is the percentage of oxygen and H2 in H2O, or the percentage of nitrogen and hydrogen in NH3, or the percentage of copper, sulfur and oxygen in copper sulfate. So this composition remains constant in every situation. Like you say you are preparing some of this molecule in the laboratory, and at the same time you are collecting these substances from the nature, right? Okay. Then you will find that irrespective of their source, that is whether they are collected from laboratory or from nature, the composition of water, NH3 and copper sulfate and their constituent particles, that is the oxygen, hydrogen, nitrogen or the copper and sulfur, so their percentage composition remains constant. That is, they are same. That is, when they combine, they will combine in a definite proportion irrespective of their source. So that is the law of definite proportion. Next we have law of multiple proportion. So according to this law states that if two elements can combine to form more than one component, then the mass of one element that combine with a fixed mass of other element are in the ratio of small whole number. So we try to understand this law of multiple proportion with an example. Say hydrogen and oxygen, when they combine, they can form H2O or H2O2, right? Okay. So when two of the hydrogen is combining with one of the oxygen, so they form H2O. Similarly, when two of the hydrogen are combining with two of the oxygen, they are forming H2O2. So hydrogen and oxygen can form both H2O and H2O2, that is water and hydrogen peroxide. Now you see, if we see this ratio, that is the hydrogen, right? So the quantity of hydrogen has been fixed as 2 number of hydrogen, but the oxygen doesn't have the fixed ratio, right? Okay. So this law states that if two element, hydrogen and oxygen, form more than one compound like H2O2 and H2O2, H2O and H2O2, then what happens? Then if we fix one of the component, in this case we have fixed the hydrogen, right? Okay. And if we alter the other component, that is oxygen, then this amount of the other element, right, the quantity of which we have altered, so they will bear a whole number ratio. Okay. How? You see, there is only one oxygen, so the mass of one oxygen is 16, and there is two oxygen, so the mass of two oxygen is what? 32. So what is the ratio? 1:2. That is, they are bearing a small whole number ratio, that is 1:2, right? So in this way we can show the application of the law of multiple proportion. Now we will discuss about the Gay-Lussac's law of gaseous volume. So according to this law, you see, when the gases combine, right, so they combine or react to produce some of the product, okay, then what happens? They combine in a simple ratio. That is, say we are reacting a gaseous molecule A and it is reacting with B to produce C. Now this A and B, they will combine in a simple whole number ratio. That is, A is to B will always be a 1:2 or 3:4, etc., etc., or 1:3. So in a simple whole number ratio, they cannot be a fraction, right? Whole number ratio. So that is a law that was stated by Gay-Lussac. Next we have the fifth law of chemical combination, that is the Avogadro's law. So Avogadro stated that if two of the gaseous system has the same volume, right, then they have the same number of the particle. That is, you see, say we have hydrogen and oxygen, right? Say we have some amount of hydrogen in a container and some amount of oxygen in a container. So there is some H2 gases and there is some oxygen gases. Now if their volumes are the same, they both have the same volume, that is V and V, so they will have same number of the atoms or particles or molecules. How? You see, say in this V volume, if there are 100 H2 molecule, then there will also be 100 oxygen molecule, right? 100 oxygen molecule. So that is the law of Avogadro's. So with the help of this Avogadro's law, we can state that every substance, if they are similar in their volume, then they must have similar number of molecules or atoms or particles in them. So that is the laws of Avogadro. So this was the very brief discussion of the laws of chemical combination. I have just given you some introduction about the 5 laws of chemical combination. Hope you have understood the topic that I have covered. Thank you for watching this video.